Okay, so let's go to question 2. Question 2 says consider the quadratic pattern. So this is now a number pattern. So you can be sure your first question is algebra, your second question is number patterns. So we now have question 2.1 is a number patterns question. They give us a quadratic number pattern 5, 11, x, 29. First question, of course, they're going to ask you find x. Okay, calculate the value of x. Any ideas? Excellent. Very, very good. 11 minus 5 gives me 6. X minus 11, this one, we'll keep it like that. And then the next one, x, 29 minus x. Okay, that's the first difference. We need the second difference. Okay, so we have this x minus 11. Can you see there? X minus 11 minus 6, that's x minus 17. And then we have 29 minus, this should be x, sorry, 29 minus x, 29 minus x minus x minus 11. So it is minus x minus 11 is plus 11. Do you understand what I did? So remember, it's now this term minus that term. So this one becomes negative x, negative 11 is positive 11. See that? Okay. So I've got, in here I've got 29 plus 11 is 40 minus 2 x's. That's 40 minus 2 x's. Okay, so I have the second difference. What do I do with that? How can I use what I have? No, you are using the arithmetic pattern. You are using this one. That's arithmetic. We're working with quadratic. This is the first difference. Term 2 minus term 1, that's the 6, is equal to term 3 minus term 2. Those aren't equal. It's these ones that are equal. In a quadratic number pattern, that second difference is equal. So that's what I'm going to make equal. I'm going to say x minus 17 is equal to 40 minus 2x. Okay, that gives me 3x is equal to, something's odd. This must be 16, sorry. No, it's not. 3x 57, sorry, 57. I thought it's 33. Okay, 57, and now if I divide both sides with a 3, I get 19, is it? Yeah. X is 19. So that x is 19. You get it? Determine the formula of the nth term. Okay, so an nth term I'm going to show you the method I like. So I've got 5, 11, 19, what was that last one? 29. So then we take the first difference is now 6, 7, 8, 10, and we see the second difference is a constant 2. Then what I like to do is I like to go one term backwards. So I know if this one was 6 and it's 10, 8, 6, this one must have been 4. So in other words, for this to be 4, okay, the first one had to be 1. because 1 plus 4 is 5. 5 plus 6 is 11. You get that? Now with this, I know that this is C, this is A plus B, and this one is A, 2A. So if 2A is equal to 2, then A is equal to 1. If A is equal to 1, B is equal to 3. And C we have is 1. So in other words, Tn is equal to n squared plus 3n plus 1. Let's quickly just test it. This was the first term. This, going backwards, I got the 0 term. But there's no such thing as a 0 term. But it just makes, because if this is 0, then I'm just left with the last number 1. That's C. Okay. I don't want to go into the reason for that now. But anyway, so this is the... Let's just test it now by putting in 1. If this is a 1, I get 1 plus 3 times 1 is 3. So it's 1 plus 3 is 4 plus 1 is 5. Let's put in 2. 2 squared is 4. 2 times 6. 2 times 3 is 6. So 4 plus 6 is 10 plus 1 is 11. Okay. If you tested 2, it should work. Okay.
Will they give you full marks for doing what you did?
Yeah, they will give you 4 marks even if you had the final answer. Yeah. So it's just a different method. The other one was to say that this is A plus B plus C is equal to 5, or 3A plus B is equal to 6, or 2A is equal to 2. Okay. I work one step back, it simplifies the equations that we have to use. Okay, question 2.1.3. They actually now give you x's answer. They say, okay, x is 19. Determine an expression for the general term. So they want the general term of the first difference. So you'll notice here, if we go back, here's the first difference. And the first difference, sorry, without the 4, I added that now, but this is the first difference, 6, 8, 10. We want a general term for that. Okay. What can you see? What type of pattern is it?
It's an arithmetic.
Arithmetic. So we could just say, well, it is a plus n minus 1d. Okay, with the first term being 4, and the constant difference was? 2. And there's 2 marks for you, right there. Okay? The next one, they say the sum of the first n terms of an arithmetic series, I'm just going to write it like that, is given by Sn is equal to n over 2 times 7n plus 15. The first question asks, how many terms should sum up to 425? If I read the question, how many terms in this series should be added to get a sum of 425? So what are we trying to calculate? What variable?
The number, is it? S425.
We're trying to find the
I'm trying to find
n. Very good. That's all I'm asking. Okay. So if n is what we're trying to find in this equation, okay, we can't have another variable Sn. So where's the 425 going to go? Sn is going to be 425 is equal to n over 2, 7n plus 15. That's it. All we need to do is solve for n. Could you do it? Okay, what will we do first?
Multiply the side of 2.
I think so. That will just simplify the expression somewhat. Okay, so let's do that. Both sides by 2, and then the n will be multiplied in here. So I'm just going to do that first. So assume I've already multiplied this side with a 2 as well. Then I'm going to get 7n squared, and then plus 15n, and then that's that. And then on the other side, this is going to be a positive answer that I'm just going to subtract on this side. Okay, so if that is multiplied twice, it gives me 850 plus 850. Okay, now this is going to be too difficult to make two brackets using the long method, so just use your calculator and find the using the formula. So n is equal to negative b plus minus, actually fill it out, so negative 15 plus minus the square root of 15 squared minus 4 times 7 times, oh sorry, this must be a negative, sorry I forgot, times negative 850 over 14, 2 times 7. What answer do you get?
There's no
No, then you didn't make this one a negative. That one must be negative.
So minus 85 over 7.
Minus 85 over 7.
Minus 12 or 942.
Which one is the answer? Okay, so why do we put it this one? Not applicable. There's no such thing as negative 85 over 7 terms. It has to be a whole positive number. Okay? So please, if you don't put the not applicable, you lose a stupid mark. So make sure you put the not applicable. Excellent. Now the next question, determine the 6th term of this series. So what are they asking?
The system shows we are, what is n equal to 6?
Okay, so you are saying we're going to calculate S6. How would you explain in words? What is S6?
The sum of the system.
Now, is that what they asked for? No, so this is equal to term 1 plus term 2 plus term 3 plus term 4 plus term 5 plus term 6. Do you see? That's what S6 is. They only want term 6. Now let me just, so that you understand what I'm going to do, we only have a formula for the sum. We don't have a formula for the terms. So if I can use the formula to get an answer for this, and I use another formula to get an answer for term 5. Term 5 is term 1 plus term 2 plus term 3 plus term 4 plus term 5. If I now subtract these two answers from each other, then these values will cancel. You see that? And I'll only be left with term 6. Okay, so whatever it is, whenever you're trying to find a single term, a term, but they only give you the sum, then you just take the sum of that terms minus the sum of the previous one. Like, for example, S6 minus S5 will give you term 6. Does it make sense why that works? Or do you understand this concept that I did here? Now this is just the sum of n terms. This is the sum of 1 less than n, which is just n minus 1. You get it? So term 6 is equal to sum 6 minus sum 5. And now we just substitute in here. If we put a 6 in here, we get 6 divided by, sorry, we're working with this one. If we put a 6 in here, we get a 3 in front. we get a 7 times 6 is 42, plus 15 is 57, is it? 57, so we get 3 times 57 minus, and this one in the bracket we put now a 5 for n, so 5 divided by 2 is 2.5. 7 times 7 times 5 is 35, plus 15 is 50, so we get 2.5 times 50. And so if I do it, see, I try and do it without a calculator. That gives me 171 if I multiply this out, minus 2.5 times 50. You could just take a 2 out, that will leave 25, and this will make it 5. So this is 5 times 25, gives me 125. 171 minus 125 gives me, well, to get the 1 I must add 6, that gives me 131, and then to go from 31 to 70 is 46. Of course you could have just used your calculator like I'm sure you're going to do, but yeah. Okay, question 2.3. They give us x minus 2, x plus 1, and x minus 3 are 3 terms of a geometric series. Okay, calculate x. Yeah, but sequence, well, it doesn't matter. Yeah. Excellent. So term 2 is x plus 1, term 1 is x minus 2, is equal to term 3 over term 2. Sorry, that's a plus. Then we solve for x. How do we solve an equation that looks like this? Excellent. So it will end up looking like we cross multiply. Whenever you have one fraction on the one side, a fraction on the other side, it looks like you will be cross multiplying. So this is term okay, and now we just simplify, multiply out everything, just simplify. So x squared plus 2x is plus 1 is equal to, sorry about that, plus 1 is equal to, this side becomes x squared minus 2x minus 3x gives me minus 5x. Negative 2 times negative 3 is positive 6. Okay, so since there's an x squared on both sides, that will just cancel. So this thing will only have one answer, which is great. Okay, the 5x will come and subtract on this side, or add on this side. That will give me 7 x's on this side, and on the other side the plus 1 will subtract from the 6, and that will give me 5. So x will just equal 5 over 7. Again, a level 3 question that when you apply the basics is actually very easy. It's only level 3 because it uses both algebra as well as number patterns. But well done, you should have been able to get it. You think you did?
Yeah, this one I did.
You think you did? Okay, here's a question. I haven't tried it yet. Hopefully I get it right. Okay, question 2.4. This looks to me like a problem-solving question. They say that the constant difference, d is equal to 4. And you must prove that the square root of S2n minus 2 times Sn is equal to 2n. Okay, so just put in what they ask you. You must now just go and do the left-hand side. Okay, so let's take the square root of S2n. So we know we're working with a arithmetic sequence. That's what they said. So arithmetic sequence, the sum S has the formula n over 2 times 2n plus n minus 1d. Now, if that is what Sn is, S2n just means every n must be multiplied with 2. So this just becomes then, so S2n will equal 2n over 2, and then instead of it being 2n, it will now be 2 times 2n. So that's 4n sorry, it's not an n there, that's an a. Sorry, that should, and so that doesn't change. This is 2a, but this becomes 2n minus 1.
So we're taking the 2n from the right-hand side.
We're taking that 2n there. It's almost like that thing we do in calculus when we have fx plus h minus fx. It's almost like that. Wherever we see an x, we substitute it with x plus h. Now, wherever we see an n, we substitute 2n. You get it? So, and in this case, all we need to do additionally is substitute d with 4 because they gave us that 4. So we can now go and substitute. So S2n is this thing. Okay, just with a d equal to 4. So this 2 and that 2 cancels. So I'm left with n. Inside the bracket I have 2a plus 2n minus 1 times 4. That is the answer for S2n. And then I must subtract, and since I'm subtracting something, I should just put what I subtract in a bracket so that it changes all the signs. I'm subtracting that thing, but multiplied by 2. So everything in here gets, well, this whole thing gets multiplied by 2, but if I multiply it by 2, it will just cancel there. I don't multiply the bracket as well with 2, it's a single term. So this just becomes n times 2a plus n minus 1 times 4. And now we just simplify. So now we can, let's simplify the inside first before we multiply the n in. So this is n. 2a plus, if the 4 multiplies in here, it becomes 4 times 2 is 8n minus 4. Okay. Minus, this one is n. 2a plus 4n minus 4. Now we can multiply in the ends. So this is 2an plus 8n squared minus 4n minus n 2an plus, no, minus 4n squared plus 4n. Now we can see the 2an minus 2an is 0. 8n squared minus 4n squared leaves me with 4n squared. And the 4n plus, negative 4n plus 4n gives me 0. And all I now need to do is show that this, the square root of this is the square root of 4 is 2, the square root of n squared is n. So I do agree, this is not straightforward, as long as you just understand that this is almost like function notation. Whenever I have term, whatever is here, I substitute into n. So if there was a 2t, everywhere where I see an n, I'll put a 2t. If there was a t n plus 3, everywhere where there used to be an n, I'll now put an n plus 3. Okay, if I have the original formula. Make sense? Good. And then let's just get to the last question on question 2. That's question 2.3. Can you see that color? Sorry, 2.5. Can you see that color though on the board? Okay. 2.5 says determine the series below. Determine whether the series below is converging, and hence calculate. So they want to know. Here's a series. K starts from 1 to infinity. Okay, 5 times 4 to the power of negative k. We must determine whether the series is converging. When will a series converge? Good. It just means r is a value between -1 and 1. Basically what it means is r is a fraction, but like 5 over 2 is also a fraction, but it's equal to 2.5, so it's bigger than 1. So it's a fraction less than 1 or bigger than -1. Okay, it's basically what it means. So we must determine that. Now how do we calculate r? It's term 2 divided by term 1, or any two consecutive terms. R is just a constant ratio, so if I divide two consecutive terms with each other, any two, it could be term n divided by term n minus 1, a term divided by the previous term. Okay, so what we're going to need is term 1 and term 2, so you have to just go and just get the first two terms of this thing. Okay, so we'll substitute in a k equal to 1. That will give me a -1 there. Okay, 5 times 4 to the power of -1 is 5 over 4. Sorry? I agree. That's not right, huh? That shouldn't be a 5.4. It should be a 5 times 4. It should be in the middle. I'll address them to not use commas like that. But do remember that it's only 5 comma. In South Africa, a comma would be a decimal. Okay, so just remember that. But you're right. Okay, but this is 5 times 4 to the power of, and please, so many people say 5 times 4 is 20 to the power of -k. It's not. You can't multiply two bases if they don't have the same exponents. Okay, this one has a 1, that one is a -k. Anyway, the next term is now when k is equal to 2. So it's 5 times 4 to the power of -2. So it's 5 divided by 4 squared. So you should notice that actually each time you're just multiplying with 1 over 4. The top is multiplied with 1, the bottom is multiplied with 4. So your constant ratio is 1 over 4. If you use your calculator, you would also get 0.25. Okay, so is this value between 1 and -1?
Yeah.
Yes, it's less than 1. It's a quarter. It's less than 1. Now we must calculate the sum to infinity. So it's the first term, which is 5 over 4, divided by 1 minus the constant ratio, which is 1 over 4. And I actually think that's 4 over 4 minus 1 over 4 gives me 3 over 4. So in the bottom I get 3 over 4. When I divide with a fraction, I tip in times. So 5 over 4 times 4 over 3. And my final answer is 5 over 3. Okay. It's good?
Now, do you need to calculate the sum of infinity?
They say, and hence calculate. So determine if the series converge. If it does converge, calculate. And whenever you see this expression, it is the sum to infinity. So if I had to calculate a sigma, I have to calculate a sum. If I have to calculate a sigma all the way to infinity, it's the sum to infinity. If that was another number like 7, I know I will be calculating S7. Okay. So that concludes question 2.